Good morning. In this video, we're going to discuss proposition 2 from book 2. So this proposition declares if we are given a finite string line L and a random point on it like P, and they divide L into two parts like A and B, then the sum of the rectangles contained by the segments and the whole L will be equal to the square on this straight line. Okay, so we are going to prove that remember the sum of the rectangle, which will be AL plus BL, will be equal to the square on this straight line, which will be L squared. Okay, so first of all, please consider proposition 46 from book 1. We are allowed to construct a square on a given straight line. So let us construct this square. Okay, so this is a square. And from point P, let us apply proposition 31 from book 1 to construct a straight line that is parallel to the side of this square. So they are parallel. And please recall both definition 22 and from book 1 and definition 1 from book 2. So in a square, we have the angles are all right angles and the sides are equal, and if a parallelogram has a right angle, then it's a rectangle. Okay, so with these conditions we know that this side will be equal to L, correct? Will be equal to the straight line because it's a square, and this is a rectangle, and since this straight line is parallel to this, we construct it like that, and they are parallel because of this square. So this must be a rectangle. Let's mark it as R1. Similarly, we can prove this is another rectangle, R2. Okay. So from this figure, we can conclude that the square will be equal to rectangle 1 plus rectangle 2. So we have the square will be L squared equal to rectangle 1 AL plus BL. Okay. And this proves our proposition. So in the next video, we are going to talk about proposition 3 from book 2. Thanks for watching. Have a good day.